Hello, everyone. This is Lucio Daza. Thank you so much for being here with us. If you are here for the webinar, Enabling Self-Service Interactive Data Analytics on All Your Data by Dremio, you are in the right place. We are going to give a couple more minutes for the rest of the audience to dial in, and we will get started shortly. Thank you. Once again, everyone, thank you so much for dialing in. My name is Lucio Daza. We will get started shortly. Thank you. Hello, everyone. Thank you for being here with us. We are about to get started. Just hang in there for a couple more seconds and we will be with you shortly. Thank you. Hello, Mukesh. And yes, to answer your question, we are going to have this recording available on our site later this week or very early next week. So I hope that answers your question. For the rest of the audience, we will have these available on our library of assets. It will be under the webinar. If you go to dremio.com/library, you will see there all these webinars and with a transcript, the slide deck, and also a recording of the video, as well as the rest of the webinars that we have broadcasted before. All right, I think we have the rest of the audience here. So I want to thank every one of you, and I want to thank you and welcome you thank you for being here with us. My name is Lucio Daza, and today we have a very exciting presentation prepared for you. We're gonna talk about enabling self-service interactive analytics on all of your data. Before we get started, there is a couple of housekeeping items that I want to run by you. And the first one, as I mentioned, is, well, actually, let me introduce the speakers. I jumped ahead of time. We're going to have today with us Jason Hughes. He is one of our senior solutions architects here at Dremio. And if you ask me, truly a genius, and he is going to talk to us about this amazing topic that we have here for you. I direct technical marketing here at Dremio, and I will be your co-host today. And before we begin, there are a couple of housekeeping items I want to run by you. The first one is how you are going to ask questions. So if you go to the Zoom interface that you're seeing on your screen right now, there is a little Q&A button that you'll see at the bottom. If you have any questions, please do not wait until the end. Go ahead and hit that button, put the question in there. In that way, we can follow up either through the webinar or at the end at the Q&A session, time permitting. Also, if you're having any technical difficulties or if you want to chat with the rest of the audience, please go ahead and put your comments on the chat window. There is a chat option there. However, please don't put your questions in there because I cannot guarantee that we will get to them. All right, if by the end of the webinar we are not able to answer your questions, we will go ahead and follow up with you via the email that you used to register for this webinar. All right, so this time is yours to learn about Dremio, and without further ado, I want to welcome Jason. Jason, thank you for being here with us, and the time is yours.
Thanks, Lucio. So what we'll go over, in kind of covering the topic of how to enable self-service interactive analytics on all of your data is first we'll start with, from data consumers' perspective, if they want this capability, what's their experience today, right? We'll go through that, and I'm sure as a lot of the attendees are aware, it's not exactly seamless right now. There are some issues there, so we'll walk through an example there, and then we'll kind of take a step back and really see how we got here, because obviously there are some suboptimal things, and we'll kind of try to understand some of the history and really why it's this way. Then we'll go through, after going through that, we'll try to understand the business impact of actually these issues and the capabilities and where we are now. To that point, we'll go through, based on how we've walked through there, we'll basically propose some requirements of what a solution to this problem and how it would enable self-service interactive analytics and what that would really look like. Then we'll propose a solution as to how we can meet these requirements for organizations. And then we'll go through, all right, now what's the data consumers experience to do the same thing, from the first part with this new proposed solution. So to jump in, let's go through what a data consumer's experience is like today, kind of broadly. So first of all, obviously a data consumer, to do their job, they generally need to answer a business question, right? There's some question that the business needs answered or some information that the business needs in order to make a decision or, inform some decisions there. So first thing that whenever you need to, answer a business question, that's, obviously a data-driven one, is that step one, you need to find the data, right? So in order to find the data, you generally, need to know where it is. So, a lot of people have, a lot of organizations have a lot of different systems. And what we see quite often is that a lot of our customers have actually told us, or a few of them have actually explicitly told us, that a data consumer, in order to find the data that they need, will actually either just go walk up to somebody's cubicle, yell across the room, right? Basically leveraging this kind of tribal knowledge, which, obviously isn't very scalable, and it's kind of who depends on what data you end up getting. And then B, once you have found a data set, how do you know it's the right one? Right? If somebody told you, like, how do you know that it's the right data set, that if you go use it to answer this business question, that it's going to be the right answer, right? Because if you're operating with wrong data or incomplete data or out-of-date data, then you will come up with potentially the wrong decision, right? But in general, what we see is that more scalably, as some people maybe go ask people, but the more kind of appropriate or process recommendation here is that it ends up being, they go ask IT, right? You need to either open a ticket or maybe someone on the inside, but basically you end up asking IT where the data is and also some details about the data, right? So they give you a data set and then maybe it's, all right, well, like when was this data refreshed? How much does it have? Those kinds of questions. And these requests obviously take time, right, to IT because they have everyone else asking these same kinds of questions. So in order to fulfill these requests, that can take time just to get the data, right? Just to find the data set that you need to then use. At that point, though, generally this data set that you get, it doesn't have all of the data that you need to answer this question. Perhaps it, doesn't have all the columns that you need. It doesn't have the full history of it, or, it has perhaps not the right granularity in that it has, oh, this is my monthly reports, but I actually need weekly, right? Or I need daily, or I need whatever it is. And often you actually need to integrate another data set. So you have a single data set, but you need to actually integrate it to answer, especially if this is a new type of business question or exploratory question, you generally need to integrate another data set. Well, how do you do that? Generally, you go ahead and ask IT again, right? Because they're the ones that have the ability, whereas you don't necessarily have the ability to do it, or don't have the ability or to do it, not from a skills perspective, but from a tools and governance perspective. So now, perhaps now you have the data that you need, or at least that you believe that you need. So now that you actually need to go start your analysis, right? So now you actually need to perform the analysis. But when you ask a question of the data, of this new data set that you've now combined with and all that stuff, you generally maybe be waiting, right? Whether it's 30 seconds or more commonly, whether it's a minute, 5 minutes, or maybe even a half hour, right? And then it's always an iterative process that you now need to go, all right, well, now I went and answered this, and it turns out that when I went and answered this question, I do actually need this additional column, or I do need this additional data set integrated, right? So then you go back to either step one or step two, right? So you end up going back there. And really, once you need to go ask IT to speed up these queries or get these additional data sets, is again, more requests to IT. And finally, this is an iterative process. Any analytics project or process really is iterative, in that you need to go ask a question of the data based on the results, then you need to tweak it, and then this becomes an iterative process. And more broadly, everyone is doing this, right? So the response times from IT, this whole process could take anywhere from days to weeks. We've actually had, because everyone's doing this in IT, it's not that they're not that they're lazy or anything, it's that there are so many requests because they need to do this for everyone. So what we've actually heard from one of our customers is that this actually, to get a data set like this provisioned from IT, it actually takes up to 3 weeks just to get the data, right? And then now you need to analyze it more, and maybe now you need to make more changes. So obviously with this being a given data consumer, having everyone do this within optimally a data-driven organization, that can cause problems. So obviously this is a problem, right? But obviously this isn't the way the organization would want to be. So why is it this way, right? How did we actually get here to this being the situation? So to take kind of a step back, a little bit further, is that data analytics really kind of started in the data mart era, right? In that analytics wasn't necessarily really prioritized. It was more of a kind of low level kind of descriptive reporting, kind of basic things, really just around like sales and those kinds of basic KPIs. So you generally had these various application databases, and they would load it into all of these different physical data marts. Maybe it's one per application, or maybe it's one per organization or project, and it's likely a combination of these, right? So you end up with your data consumers with these different tools that they have at their disposal, but they don't really know where to go for what data, right? So obviously you end up you need to involve IT a lot in this situation. So as analytics really, as this became more and more of a problem to run your business, well, we needed to kind of do away with these individual physical data marts. You never any idea where any of the data is. You're recreating new things that everyone else is doing. So where next came was the EDW era, right? Where you had this single data warehouse that you would optimally load all of the data in. Now you would have all of your data in one store that you could actually perform your analytics on, right? And that works, it works really well for the problems that it needed to, but there was still inevitably some side data marts from a resource and governance perspective, because these data warehouses tended to be fairly cost prohibitive, right? To actually get to all of the data and all of the permissions and everything that you wanted. So there ended up still being physical data marts, and these were both dependent data marts, as in the data mart on the left here, that you see is just from the EDW, but also independent data marts, right? From specific application databases that would be loaded directly into it. And this worked, fairly well. It definitely had its a couple cons there, as I laid out, but really the demise of this kind of architecture really came with big data, right? Where you had the velocity and the volume and the variety of data that the data warehouse it wasn't built for that, right? It just wasn't designed that way. And it certainly wasn't cost effective to store this kind of low value density data that really came in with the advent of big data. So where then the next architecture kind of era came in was around the data lake, right? So now the kind of thought was, well, can we load all of these different types of data, the different value densities of the data, right? Can we load that all into a data lake where, it was great because you could treat it as a central data repository. It was really scalable. You could decouple the compute from the storage. I know, Hadoop kind of started scaling them both, but, the architecture itself, you could in theory scale them independently, and several organizations did. And also it was a file system, right? So it ended up being schema on any format you wanted. So you can now store a lot of the logs, audio, video, a lot of those things where you weren't restricted into what kind of data you could store. So you could just dump it into a single place and you could retain that. It was also very cost effective, right? It was built on commodity hardware. So again, the scale that you could achieve with this was actually, it now was cost effective to store all this data versus throwing it out. But at the same time, there were cons, right? So this is kind of prosed architecture, and this is certainly simplified. There are probably a lot more databases and things. But in general, in order to get self-service for your data consumers, you needed some sort of programming background. Maybe either that's, writing Java and like MapReduce, or, the advent of Pig and those kinds of things that simplified the language. But in order to get real use out of it, you needed to understand what was happening in the background. Because if you just wrote whatever query you wanted, chances are it could take, a couple of days just to run that query if you didn't understand the architecture and what was happening behind the scenes. Also, even if you did know, you often ended up with poor performance if you didn't have, if the data wasn't physicalized in a way that was really for that application, right? In order to really get performance out of it, you needed to perform application-specific ETL. In addition, you ended up with, it was very hard to find data in the data lake. And on top of that, there was a lack of governance. And really, both of these two things led to, what a lot of people ended up calling a data swamp, right? And that it was, the data was there, but it wasn't super useful, right? Like it was hard to find data. It was hard to, people were making copies everywhere, right? And even if you did find it, it was difficult to use. So all of this kind of led to the fact that you had all of this data stored, but it was very difficult for you to actually get real value out of it, right? The ratio to that was relatively low. So what we had to add was like, all right, so now that we have all this data in the data lake, well, can we add something to it, right? Well, what we added was the EDW. And this isn't necessarily chronological, right? Like, of course, the EDW was around, but it's more about the data flow, right? Now everything is loaded in the data lake. Well, now we need to load more of it into the EDW. And this provided a lot of benefits, and really offloading the cons of the data lake was really what it was about. And it was great because, it was traditionally, it's been more performant than data lake execution engines. And that these things have been honed and around for a while. The cost-based optimizer is very good. It knows about the structured data storage. It has several optimizations it can do to really increase the performance for your data consumers. It also was high concurrency, so you could really run a business off of these, in that you could have 100,000, 10,000 data consumers against this single system, and it could still provide them with that analytics and interactivity that they needed. It also provided high guarantees and would consistently meet your SLAs. So to use the data consumer, if you issued a query today, you knew that if you go into a meeting and you're loading this dashboard or whatever, you would generally see like consistent performance there. And another big thing was that it really provided that security and governance. So now that you can actually control and really make sure that your users actually have the from the perspective of governance, that not everyone's creating copies everywhere, but also obviously from a regulatory standpoint, right? That now you can control who sees what, and audit logging and those kinds of things, right? So those things were great, and it really served its purpose there for those things. But at the same time, right, there were also cons to this approach. And with that, it's expensive, right? And oftentimes is that while it's traditionally more performant than a data lake, because it's expensive, you can't necessarily optimize from a performance perspective for all of these different types of queries. So you had to basically pick and choose because you were pretty cost constrained. So what you ended up doing was that you ended up trading off one to the other, and now some portion of your users wouldn't have the performance that they need. Yeah, the executives would, and the really important, like high priority applications would, but not necessarily everyone. Also, because of the cost, is that you end up with a subset of data, right? Is that you can't load all of the granularity or all of the columns or all of the data sets into the data warehouse, because there was this issue with the, basically cost of it. As well as sometimes even the scale of it, right? That sometimes it also couldn't scale depending on, if you're a web scale company, perhaps. Another thing is that in order to use this data warehouse, and everyone's accessing the data warehouse generally now, in order to use that data realistically, you actually needed to load the data. So before you even used the data, if it wasn't in the data warehouse, or you needed new columns or the granularity or those things we went over before, you actually needed to have someone load the data into the data warehouse. And again, from this cost perspective, is that you generally needed to justify it, which doesn't really help for like exploratory analytics, right? Also is that, going along with that is that not all of the data is in the system, right? So again, you need to have people load this data, and it makes you dependent on this outside group that's getting these requests from everyone. Another big part was that these data warehouses are almost all proprietary, right? So you ended up, well, okay, maybe these things are, it helps me here, but it also locks you in to the future. And it doesn't really give you much flexibility to do what you like to do, right? You're kind of beholden to them. So again, kind of the same theme of like, all right, let's keep the pros, but try to offload the cons, is that we added, BI extracts as one piece. So now we actually had extracts from the EDW, and that was great because now we could, for all of these performance requirements that applications, weren't meeting the performance, we could now meet them because now you do all of these performance optimizations in the BI tool, and now the dashboards load quickly for the most part. You could also join data from multiple locations. So if not all the data is in the EDW or you needed some granularity or whatever, you can now do that in the BI tool, right, in theory. Again, the key to these, though, is really as long as it fits. When you get to kind of data scale, you end up with the fact that this kind of breaks down because now you end up with the same problems that at larger scale, it's a single server. It's not a scale out architecture, it's a scale up. So you end up with, all right, now I need to choose the subset of data, right? And now maybe, now they're also not engines underneath. They're not execution engines really underneath the covers. They're really meant to be that way. So if you're feeding a large dashboard, you can also hit performance issues. From like maybe I'm not meeting, date's not running as fast as quickly as I want, but also inconsistently, right? You can also hit inconsistencies in dashboards, again, because they weren't really meant to be execution engines under the covers. Another piece is that, any of these improvements, performance, and these joining was only specific to that BI tool. So your SQL client, your data science, even Excel or whatever tool your users wanted to use, well, they didn't get these benefits. This only worked for the specific, not only BI tools, but that specific BI tool and that specific instance of that BI tool, right? Which you could have many BI tools and many instances. Another big problem was that the business logic that you built into this is actually only in the BI tool, because now you end up with, okay, well, now I need to do the same logic in different tools. Well, now you end up with, these people have different definitions of KPIs. So now you're going into meetings and somebody's saying this was our churn or this was our revenue or whatever for this quarter, and somebody's saying, well, no, I'm seeing a different number. And now you need to go back through and trace all that back, or it ends up being just wrong and you only see one of them and you're making a wrong decision or a less optimal decision based on that data. Another piece is that it's still really IT managed, these extracts. So you still lose that self-service piece with the performance, right? Again, as you guys can see, that this as you go through this, you generally have to pick a couple and deal with the trade-offs, right? And then you end up offloading the trade-offs. So if these were potential issues for a given application, well, maybe what then they would go with is a physical data mart, right? Bring those back into the play. Because it was great, because now they own that generally organizationally, and now these users could have more self-service, and they could really have the flexibility and agility to achieve their goals from a self-service standpoint. And they also have the performance, so now they can actually really build these applications, and they're now much happier in general, right? Because they can do a lot more themselves. But obviously, you guys maybe get the theme now. There were a lot of issues around, of course, the governance and regulatory. Right, so now you have data copies everywhere, as you can see. So how do you really keep track of not just where the data is, and especially with GDPR and those kinds of privacy laws coming into effect of deleting someone or a record about someone, is that how do you control who had access to this, and how do you know who accessed it, right? There's also a cost perspective in that you're not running all of these, right? This is obviously oversimplified. There's more than just 2 data marts and probably more than 1 EDW and probably more than 1 data lake, right, in the environment. So you end up with the cost of actually running all of these where you don't really necessarily need to. Another big piece was the data drift. So we talked about the business logic drift of the incorrect decisions or conflicting numbers and those kinds of things. Same thing happens with the data drift, right? So you end up with that in the situation. Also, really wasted effort around, if you're looking to do this, answer this business question, and you're analyzing some customer trend. Well, it turns out, marketing has already done that, but you're in, I don't know, operations or business development, and you don't necessarily see that. Well, now you're replicating that effort, and you're wasting, amount of time, but you could really just leverage that optimally, right? And again, going the same thing of the data and logic drift there. As well as, each group now needs to have their own IT in that where they're managing these physical data marts, we still need someone to manage and operate this cluster as well as the jobs that run inside it. So now you also have your own IT that you need to staff. So as you can see, right, this is kind of a mess. And this is in fact simplified, probably greatly. So, with all of this kind of a given architecture, obviously this is a fairly big, it's a fair generalization, but it's really based on what we've seen in the past and, what certainly I've personally seen. And so what we end up with is with an architecture and a process and a consumer experience like this is that you end up impacting the business, potentially fairly significantly. So certainly you end up with, as we discussed before, right, you end up storing a lot of data, but really the value that you get out of that is relatively low than what the data lake era promised, right? If you're going to have all this data, you'll get value out of it, great. But as you've seen, to really make that data usable, it's traditionally taken a lot of effort just to get an application built, let alone application change, let alone exploratory analytics, right? You certainly also lose a lot of productivity in that when a data consumer asks a question, they're now waiting 30 minutes to get an answer from that single query. But also now, as we've gone over before, right, they now need additional data to really answer that question. Again, you can be waiting from days to even weeks. So between that time, what are they doing? Maybe you have additional questions that they're answering, but again, you end up with, they're not really able to focus, and there's the context switching problem, of course. So you end up with a loss of productivity there, as well as on the IT side, right? Because now the IT and data engineering is shipping this data around and replicating this effort as well for all these different groups, and that they could be focusing on a lot more or higher value things as well for the business. You certainly end up with late decisions, right? So it takes 3 weeks for you to get a data set, and certainly could delay the decision, especially as you need to move agilely, right? And if your competitor comes out with something, you need to answer some questions, takes 3 weeks to do so, that's obviously a problem. Wrong decisions, as we've also gone over, around 2 different numbers, or the data's out of date and you don't even know it because there's not an alternative. You end up with these kinds of wrong decisions as well, especially with the complexity of all these different pipelines of moving data around, right? If something fails, or so there's some issue with it, then you end up with, certainly it's hard to manage all of this, right, with the very high complexity here. As well as the regulatory compliance issues that we had mentioned before around physical data mart specifically, but overall, if you look at this kind of architecture, data is copied everywhere, right? And it was hard to keep track in data discovery within a data lake, let alone this entire ecosystem, right? So it's incredibly difficult to maintain and track all of that, as well as waste of time and resources, right? So you're not just wasting the time of data consumers and data engineers as we've gone over, but also the actual resources of these systems that could be better put towards actually the data consumers' questions now have to do a lot of this copying, a lot of this ETL, a lot of this ELT, a lot of those kinds of transformations, right? So with that, with that kind of understanding of kind of how we got here and why it is the way it is for these data consumers, what kind of options do we have? So what we'd like to, kind of go over now is this kind of goal state of what we can, you can call it whatever you like. For now, we'll call it, self-service interactive analytics, and that they can do it themselves. They get interactivity and they can run their analytics. So first, from a data consumer's perspective, right? Because generally the requirements drive from the business to the data consumer to the data engineering and IT. From data consumer perspective, they have a series of requirements. Like, right, it needs to be self-service. They need to be able to do these things themselves. They need to be able to be self-sufficient at the end of the day. You really need to have that kind of experience in your life of, Google, of being able to do all of these things and all of the technologies that you have in your personal lives, really bring it to your business. You also need to have data discovery. You need to be able to find the data. You need to be able to understand the data, right? From like a semantic perspective of these terms need to mean the things that I think they do. And you need to be able to trust the data, or at least understand the level of trust that you can put in a data set, right? So you need to have these kinds of metadata and these kinds of things. You also need to have any data, right, that you actually need for your analysis. If you need to augment it with another data set, if you need to get deeper granularity, you need to be able to do those things yourself. You also need to be able to, chances are the data isn't in the exact format that you need, right? You need to probably do some curation and this augmentation. You need to do these things, to be able to do these things yourself, right? Whether it's reformatting a column, extracting a piece of a column, or whatever it may be, right? You need to be able to do these things yourself. You also need to have, all right, you can do all these things, but you really need to have interactive performance, right? To actually provide these, all right, I can ask these questions, I have these capabilities, but if I'm waiting 30 minutes for an answer, you know, you're going for a walk or grab several cups of coffee. So you also need to be able to collaborate, right? Going back to, it's kind of on the other side of that data discovery piece, in that once you save the data set, you need to probably, you know, nobody works in a silo. So you probably need to share it or send it to some other person. You really need to be able to make that collaboration lightweight and really practical as well. You also need to be able to leverage your existing skills and tools of choice, right? Anytime you make data consumers learn, or anyone really, new skills or new tools, you're upping that barrier to entry that much, and they're gonna end up finding a way, probably with you know, downloading things to Excel and those kinds of things, and that it really needs to be able to leverage their existing skills and use whatever tool they want. So with those kinds of as the data consumer requirements, what ends up being, you know, with these, if we can provide these, what ends up being the actual IT or data engineering requirements of this platform? So from a functional perspective, they need to have, of course, security and governance throughout, right? You need to be able to really secure the data. You need to have those governance policies that you can enforce. And you also need to have audit logging throughout, right? You need to be able to understand throughout this entire ecosystem, you need to be able to control it and understand what happened. So you also need to be able to meet these SLAs consistently, right? Business, what's application, you know, we have a customer that's, you know, in an exec meeting, they really need to be able to ask questions of this interactively, and you can't be waiting, you know, 30 seconds or a couple minutes in order to do this, especially in the C-suite. You also need to be able to, you know, to fulfill requests. There's probably always going to be requests, right? That self-service aspect is kind of a spectrum, anywhere from fully decentralized to data consumers can do anything they want, to fully centralized of IT basically controls everything, right? That's kind of a spectrum where you end up fitting somewhere on it. So there ends up still certainly being requests that IT needs to fill for the data consumers specifically. So they actually need to be able to fill these quickly, right? Not copying data from system to system to system where it's already been done, and then maintain monitoring and all those kinds of things. You also need to be able to enable agile development for these data consumers. So they need to be able to develop their the actual applications and all these things while also allowing them to do it in parallel, right? So somebody doing it in marketing shouldn't impact someone doing it in operations or sales or wherever. So you need to really provide this multi-tenancy, not just from a technical perspective of so many users can be on it, but also organizational multi-tenancy, right? Or domain multi-tenancy. So now onto the kind of technical requirements here of the actual platform. It needs to be linearly scalable. You need to be able to scale these things as you increase the number of users, increase the amount of data. You need to be able to maintain these SLAs and these capabilities. So it really needs to be not just scalable, but also linearly scalable, right? Can't be adding, all right, you add 2 users, now you need to add 12 nodes, right? You can't be adding those kinds of things. So you also need to decouple the compute from storage, right? I think throughout the industry, we've all kind of understood that this is a good thing, and this is something that really brings a lot of benefits, and that's something it's pretty much a given at this point, right? So it definitely needs to be able to decouple the compute from the storage, but it also needs to decouple one step further, the logical from the physical. Your users need to be able to operate in this logical semantic layer, especially from a multi-tenancy perspective, right, of different domains that view the data, same data, but slightly differently. You need to be able to decouple that logical experience that the data consumer has with the physical actual where the data is stored, and also how you're optimizing the data from a performance perspective, right? Your users, shouldn't have to care, and they probably don't care. Right. At the end of the day, if they don't have to care, they don't want to about where the data is stored and how it's stored, right, and how it's optimized. Which also gives you the ability to basically be tool, data store, and cloud agnostic, right? Because on the top you have your tools that access it, they access the logical layer, but then below this, this platform, you would basically have any data store that you want and any cloud that you want to run this on. And A, that helps for flexibility initially, but B, it also really future-proofs you in terms of, it gives you the flexibility and the peace of mind that in the future, you won't have to completely re-architect these things, right? And it has to be cost-effective, obviously. If we end up back in the EDW era of these things being expensive, you end up with the same problems. You're going to choose a subset of your data. It's going to be hard to justify these applications, exploratory analytics, those kinds of things. So with this, these kinds of the requirements that are, generally the high-level requirements for these things, what we can, kind of look at is this kind of architecture, right? And that you still end up with all these various source systems. The source systems are in gray where the data is actually coming from. And you generally want to load this into the data lake, right? You want to load that in there. You want to have a central place. You don't want to be hitting all these different sources. A lot of times these are external sources, right? So you need somewhere to put this data. And that's still, probably going to be the data lake because it is good as a cost-effective, scalable storage system for any data format, really, right? And you end up also with the EDW because, it certainly serves the pros that we went over is certainly positive things. But at the same time, again, you really need to be able to offload the cons. And that's where this platform comes in that enables self-service interactive analytics on your data in any of these data stores, right? And maybe sometimes it actually makes sense to connect the application database directly to there because the application database loads it into like the data lake every 12 hours, but for certain applications, you need it every 30 minutes or you need it real time, right? So you need to really provide this flexibility and really decouple your users who iterate at that logical level from actually what's happening behind the scenes in the physical level, as long as it doesn't impact them from the performance, from the discoverability, from those kinds of capabilities. So what we kind of propose here and what we've seen at Dremio is that Dremio can actually serve as this self-service interactive analytics platform, and that it can, it really provides, and as you can see, kind of decouples the users from the actual storage medium. And we'll certainly go through exactly how Dremio does this, but just really briefly on Dremio itself, for those of you who may not be fully familiar with it, is that it provides a self-service semantic layer for data engineers as well as analysts and, kind of data consumers. So it provides the self-service, the semantic layer. It provides a UI and also that is really user-friendly and intuitive, even for non-technical users. And it also basically provides the same kind of experience from whatever tool you're using from. It really meets the tool where it is. It also provides, really incredibly fast queries directly on your data lake storage or, wherever that data may be stored. And primarily, the first place it's going to land is the data lake. And optimally, you don't need to move it from the data lake if you can address and mitigate those cons that we went over before. So there's no need to really load the data into a lot of proprietary data warehouses, create cubes, extracts, physical data marts, those things that we went over before, if you can get the performance and those other capabilities directly on the data lake itself. Of course, this is any environment now is, the pendulum swings from decentralized with the physical data marts to centralized with the EDW, now back to decentralized, and it's probably not going to be fully centralized for a while, right? So what you end up needing to do is you really need to be able to join and be data store agnostic and really be able to join databases and data warehouses and application databases and file systems and whatever, right? You need to be able to join all these things to provide flexibility. And also, it really needs to operate on open standards. So again, with that kind of, you want to avoid the lock-in as much as possible, and you really need to be able to operate on standards. There's open standards for most things now, especially in the data storage space in terms of file formats and data stores and those kinds of things. You really need to operate on standards as much as possible. So with that said, let's dive deeper into exactly how Dremio meets these requirements, right? So we'll actually walk through each of these. So from a self-service perspective, Dremio actually provides that self-service semantic layer, right? For technical users, they can certainly use it, but they've never really had as much of a problem, right? But really, it's also very intuitive for non-technical users. We have quite a few customers at Dremio that, they're actually able to provide business users with a very intuitive experience that they generally could only get with something like, like business objects, right? That data non-technical users generally like. But they've also really enjoyed and found great use and productivity in Dremio's UI there. It also provides you a lot of data discovery and understanding and trust via the ability to search on data wherever it is, right? So data lake, data warehouse, application, database, wherever it is, if it's connected to Dremio, you can search through it. It also provides you, the actual ability to browse lineage and view how a given data set was actually created, and therefore, some information about its provenance. As well as it also provides data set wikis and tags. So you can actually see, some general documentation about it directly in the tool without leaving. It's just a single click over to the next piece in the page. And unfortunately, we don't have time in this session to actually go through a demo in this to really show you these kinds of things. But Lucio certainly does a great job with the live demos every Tuesday. So we certainly have that, or you can follow up with us to actually see it. And I think there's some videos hosted online. But moving on is that it also needs to provide any data needed for the analysis. Well, with Dremio, you can look at data at any depth. You can look at whatever history, granularity, multiple sources, multiple data sets. It really allows you to look at any of this data, again, in a self-service manner, right, doing it yourself. Also looking at all that data, you also need to, again, that curation aspect is that in Dremio UI, you certainly have the visual curation. But again, you can also do it with pure SQL, if you like, from any tool that you like. It's, again, ODBC, JDBC drivers, as well as a REST endpoint. So you can issue SQL from wherever. Basically, whatever tool you use today can likely work with Dremio. You can do these kind of last mile ETL or this kind of curation without making any copies of the data. So you're not making copies of this data like traditional data prep tools. It's actually all logical in SQL. Also provides you, the ability to do all of these kind of augmentation and these things in a self-service manner, as well as actually upload. So if you have like an Excel spreadsheet that you actually want to augment and put to your data, you can actually do that fully MPP in parallel via just uploading it to Dremio and joining that data set to the one that you're working on. It can be a two-step kind of process. It also provides, so with all of these capabilities, that's great, but if it takes you 30 minutes or an hour or 3 weeks to do these kinds of things, it's not really that useful, right? So you also need to be able to provide this interactive performance with all of these things. And that's where Dremio, really we have a scale out architecture. So it's full MPP. One of our customers is actually running us on, like hundreds of 700 nodes. So it certainly has the scale out architecture. It's Apache Arrow based execution engine, which is basically highly optimized, takes really a great advantage of some advanced, some modern rather, CPU architectures such as vectorization like SIMD. It also provides, within the bottom, and Apache Arrow is open source, so is Gandiva, which is you can kind of think about as a execution kernel around Arrow, and that it does some very low level optimizations in that you really want to optimize for the inner loops, right? If you can as much as possible, because that's where generally a lot of things spend the most amount of time. So Gandiva will actually compile instructions to machine code. So it'll actually take full advantage of the wide registers and those kinds of things that really can really highly optimize a lot of operations there. It also provides columnar cloud cache, which is basically instead of going to like a cloud data lake, which is high throughput, but also high latency, we're actually able to autonomously and transparently cache some of that data locally, right? So then the next query comes and turns out we already have it. We'll go make sure that the data is fresh or hasn't changed. Then we'll actually go use that data instead. And all of those things are actually fully transparent to the end user. However, we also have the capability of what we call data reflections, which is a whole session on its own. But you can kind of think about it in a way that these things help your given query. But at the end of the day, if you need to scan 10 terabytes and do aggregations across 20 different fields, you're dealing with physics at that point, right? You just have to go do that work. So reflections is really what enables you to, instead of doing it at runtime, well, your users still want interactive performance, or your dashboard needs to load in sub-second, or whatever it may be. Well, let's actually go ahead and do those operations ahead of time, and then let's store that result, again, behind the scenes, and then when users ask for that, again, without changing their query, they issue the exact same query, Dremio will actually recognize using relational algebra that it can substitute this reflection instead. So you also have that ability as well to really optimize where some of these, if you need to get it from, tens of seconds down to sub-second, you have that capability. In addition to that, also around the collaboration is that Dremio is full server-based. So you create these data sets, and it's all server-based. You're not copying the data out, sending it over, ending up with these drifts and these copies of data. And you also have the wikis and tags there. In terms of leveraging this existing skills and tools of choice, is that Dremio fully operates on standards. It's one of the core maxims that we really operate on, is that let's meet the users where they are, right? Let's not make users change their behavior. So the industry has spoken, SQL is the de facto standard. Full ANSI SQL is what we run as well as ODBC, JDBC, and REST API endpoints, so you can consume from any tool, as well as Aeroflight as well, which is an upcoming standard as well. So that's how Dremio meets those requirements. Let's now go through how Dremio meets the actual IT requirements. So as we go through, let's first go through the functional requirements that we've gone through. So the security and governance throughout the platform and throughout the environment, right? Dremio actually provides security at the source level, the PDS level, which is a physical data set. You can think about it as like a table. The virtual data set was kind of like a view. So you have both of those levels, as well as a space, which is a unit of organization. So you can basically how you organize it and secure. You can fully nest those. So you have any arbitrary depth of, really this tree building out, as well as row and column level. So you can enforce security at any and all of those levels. And it also provides, audit logging in terms of who's actually interacting with data, who's doing what, as well as full end-to-end encryption, all the way from reading the data to returning it to the client. It also needs to, again, meet SLAs consistently. How we can do that is through, again, a scale-out architecture, add 10% more users, add potentially 10% more nodes. Potentially, you won't need to, maybe only need 3%, maybe, something like that. Also, workload management is certainly a key piece of how you can manage and consistently meet SLAs and ensure that different people basically can see the consistent SLAs, as well as the reflections, right? So you can actually, as we discussed before, instead of doing all this work at runtime, well, if you can do most of it ahead of time, it really helps meet those SLAs consistently as well. In terms of enabling IT to get high productivity, fulfill requests, decoupling the logical and the physical there is huge. Because now either they ask for a new data set, you can go build it in the logical layer without even having to worry about, you don't have to do any data copies, you don't have to move it from system to system, you don't have to really worry about that. And then also from a kind of, okay, well now it's too slow, right? Or it's slower than I need it to be. Now you can go optimize the physical in the background, whether that's moving it to perhaps a higher performance data store, like from maybe like a cloud data lake, to a local like Hadoop cluster, or even a relational database or something like that. Or you can actually optimize with reflections. Again, and this is all behind the scenes, so it doesn't impact the users at all. It segregates those two layers. You also have the visual curation if you so choose to, but SQL if you really want to. Again, it's all standards. You're not doing with a visual thing that you're like, all right, well, where's this menu button? It's all standards and those kinds of things. As well as reflection creation. To actually create these reflections is much more of an agile process, and it can take you, hey, a query is slow, you can go look at it, and you can specify a reflection to be created in, a minute, perhaps. Sometimes, of course, it takes longer, but, if you understand it, it can be up to, a minute to actually create that reflection, increase the performance to fulfill that request. Also enables agile development. And basically, again, decoupling that logical and physical really helps that agile development, as well as promoting from dev to test to prod. So kind of that kind of promotion process where you have different levels of governance through each layer, right? Different controls, as well as spaces, so organization and control through that way. Along those same lines, basically the multi-tenancy, right, around workload management. Certainly multi-tenancy is from a technical perspective of, hey, there's a whole bunch of users on here, I need to make sure the queries don't hit each other from a workload management perspective, right? But there's also the domain organizational multi-tenancy. And that was really where decoupling that logical and that physical really helps as well. Because now you can have group specific or application specific semantic layers that all leverage the same physical performance optimizations underneath the covers of these kind of reflections and all the other, and Diva and all these kinds of other pieces that we've gone through. From a technical perspective, we, again, from a scalability perspective, is that it's full MPP scale-out architecture. So again, you add 10% more users, you'll add up to 10% more, but you're not adding 50% more, right? It's a scale out architecture. Also, from a decoupled compute from storage, you can, and we recommend actually running Dremio on non-storage nodes. So you can certainly run it like co-located on the Hadoop cluster if you'd like, and you benefit from things like data locality, but you can certainly scale Dremio fully independently in the storage. Or you can run it on like Kubernetes, which you run it, again, fully independent. Again, from that decoupling the logical and the physical, the benefits there, we do that via virtual data sets, reflections being tied in the algebraic matching. So it's not like a given data set. Even if you build up this data set over to the right and you end up using one over here on the left, it's completely different. We can actually use the reflection on the one on the right if it algebraically can. Also from the connector architecture that we have, so you don't really worry about the source. You use the same language. All that changes that Dremio manages the translation of to the connector, as well as data source abstraction using that same method. Again, from basically being agnostic of these things, it again operates on standards, the connector architecture, and it can run anywhere, right? So you can use any tool because generally they speak those standards. You can use any data store because it's connector architecture, as well as you can run it anywhere on any cloud, right? Especially with Kubernetes, but again, Dremio's can also run certainly on AWS and Azure, and it can basically run on a hybrid cloud architecture as well. And it's also future-proofs you, right? So you don't need to worry about different tools that come tomorrow. ODBC, JDBC, REST, different data stores that you now need to load it into. Great, you have the connector architecture. Different clouds that you want to run on in the future. Great, it doesn't matter where you run it. As well as a cost-effective nature is that, again, you've decoupled the compute from storage. We have a very efficient engine. So it's not just when it's running, but actually from it, we highly optimize and focus on the efficiency of it. And you can also scale it out and in, right? It's an elastic engine. So depending on your demand, you can actually scale it out and in. It's not this kind of static thing. And because Dremio isn't actually storing the data, it's very simple and easy to actually scale it out and in. As well as, reflections, which can greatly reduce the workload there. Because you're not necessarily doing all of the work for 100 queries, you're doing it once and then serving those. So that can help make it cost effective as well. So now, from a data consumer's perspective, in this kind of future state, you now need to answer a business question. Now you need to go find the data. Now, where is it? Well, now you can go search for it, right? Using your keywords, or you can also browse for the data if you want, right? And how do you know it's the right data set? Well, data set like it has a wiki. It has descriptions about it. You also know where the data set's actually located, and there's some information about that. The tags on it, as well as you can also see how many people have actually used this data set, right? If only 5 people have used it, probably less trustworthy than the one that's been used 10,000 times or 1,000,000 times. But now you need more data for your question, right? You looked at it, and that's not necessarily it. More columns, more history, lower granularity. All you need to do is change your query. You just change your SQL, and you've now gotten it. Now you actually need to integrate with another data set. You can actually click join in the UI, and Dremio actually recommend joins for you. Or again, you can just change your query, right? It's this self-service kind of nature that you can do these things yourself. Now you actually go perform your real analysis. Your queries complete quickly due to all of the things that we went over, right? The scale-out architecture, the execution engine, Gandiva, C3, Cloud Columnar Cache, as well as the reflections, right? And now you need more data. Again, go back to step 1. Great. All of these things are self-service. Because this whole thing is still iterative, that hasn't changed, but now each process in there is much, much faster. So that really means that now from days to weeks, you can now achieve this in minutes to maybe even hours, depending on the analysis, right? Certainly from the broader picture is that Dremio, we recognize that this is certainly a large piece of self-service interactive analytics, but there's certainly other pieces, right, that kind of fit into the picture overall. And that's from anywhere from other analysis and operations, from, kind of the long haul ETL that takes 24 hours to do all these transformations. Certainly that's in the picture as well. You're probably using something like Spark. Also from the streaming and real-time analytics, as well as kind of an OLTP workloads. We recognize that that's around in the ecosystem, and we certainly work with a lot of customers to have Dremio coexist with these kinds of things, as well as other kind of data types, right, in terms of unstructured data. Where it's semi-structured, structured Dremio is great, but it's not necessarily built for unstructured data and these kinds of things. But again, we have many customers where these things coexist, and of course in the future, right, there is no single tool for absolutely everything. personally, I've seen Dremio be one of the tools that satisfies and addresses most of these requirements than I've seen any other given tool do. But at the end of the day, the platform should really use open standards and open formats so all tools and processes can really coexist to mix and match them to basically achieve the business requirements, right? And, kind of that's great. We've been talking about this, but, kind of the proof is in the pudding. We've actually done this with a large number of organizations and some of the largest data organizations that there are, right? So all of these customers are actually using this approach with Dremio to actually provide their data consumers self-service interactive analytics on all of their data. So with that, I wanted to hand it off back to Lucio, but here's certainly some resources for you that you can go ahead and try Dremio out. But Lucio, you want to talk a bit about that?
Thank you. Yeah, absolutely. And now I want to encourage everyone who caught that last line to go and get some pudding at the end of this webinar. Now, thank you, Jason, for saying that the proof was in the pudding.
Sounds pretty good.
Definitely. Thank you so much, Jason. This has been an amazing amount of wonderful information. And before we jump into the Q&A, we still have a couple of minutes. I want to encourage everyone to go to our deploy page. This is a change that we did a couple of months ago. Now we don't have a download page, but we have a deploy page where you can see all the different deployments options that you have for Dremio, depending on the on what cloud flavor you are working with, or if you want to launch on-prem, or if you want to figure out how is it that you can use Kubernetes to launch a containerized version of Dremio. All the information is going to be there. Also, please go to our tutorials and resources, and go to dremio.com/tutorials and resources. We have a ton of information in there, a lot of tutorials that you can see and you can read through to learn how to use Dremio with any BI tool that you might be working with. And of course, go and join Dremio University. Is an online learning platform that we have created for the community. You can register for free, and you can take any one of the 7 courses that we have there for free as well. And it gives you the opportunity to launch an instance of Dremio. It would be your private virtual lab with Dremio Enterprise Edition in it, so you can take it out for a spin and follow along with the exercises that we have in there. And as Jason mentioned a few minutes ago, I host a weekly demo on our site, so please go ahead and register for that if you would like to see how is it that we tackle all these use cases that Jason was talking to you today about in real life. And in addition to that, please, if you have any questions, always go to Dremio community. We are actively looking at it all the time, trying to answer questions. We have a lot of smart people across the community, always posting new challenges in there and helping each other and answering questions to help the rest of the community. So we still have a couple of minutes. So I think we have a time for one question before everyone goes. And Jason, one of the questions that we have here, we were talking about performance throughout the presentation. And if you can summarize in the next couple of minutes, how is it that the question is, how do you exactly achieve your performance SLAs using Dremio? So is there anything that you can share with us there in that aspect?
Yeah, certainly. So I know we're running up to the top of the hour, and that's I could probably talk about this for a while. So if anybody wants to follow up on that, I'd be happy to have a conversation about that. Absolutely. But in general, it has to do with the architecture of Dremio itself, and that is full MPP, so you can scale out. We've also highly optimized Dremio to especially read from a lot of data lakes, especially cloud data lakes. So cloud data lakes have some specific traits or attributes, especially around some of the requests, and that it's high throughput, but it's also high latency. So especially when you're reading columnar formats on there in big data, there's a lot of waiting that you end up doing for that. So we actually end up developing a capability that it's not just generally IO, there's read ahead, but it's actually column aware read ahead. So it's not just read the next bytes. It's, well, if it's the next column, well, let's just go ahead and read the next column and skip ahead to that instead. So there's certainly that in terms of what we call predictive pipelining, and going ahead and requesting that kind of stuff ahead of time to expect what the query will need and what the users will need, as well as the columnar cloud cache that I had mentioned. All right, so now we have this data locally. Well, we've read it once. We don't need to go ask SB or ADLS or whatever for it again and wait another. I mean, we've seen anywhere from, of course, low latency to up to like 5 to 10 seconds for a request. And if you're trying to complete your query in 1 second, that's obviously not possible. As well as the execution engine itself based on Apache Arrow, as well as, Gandiva, really getting that taking advantage of the machine level and new CPU architectures, as well as, certainly data reflections. And that's really where if it takes you, again, however long to scan 10 terabytes of data, well, there's no really way around that, right? You can't really beat physics. And that's where data reflections can really help you. And, just to maybe kind of provide one more piece of color here is that we've actually had a customer who we went in, we're talking to them, and they wanted to go ahead and test out Dremio. We tested in a POC, and they had a query that was running on the other vendor called a modern big data engine. And we ran that given query, and it took it 28 minutes. We actually ran the exact same query in Dremio, like out of the box, just deployed in a bunch of nodes, and it took it 40 seconds. So if 40 seconds is good enough, that's a significant improvement, and then we could be done. But actually what they really wanted was they wanted to see if we could get it to sub-second. So that's when we actually brought in data reflections, and we created those data reflections to actually get that query to be sub-second from the 28 minutes. So it really provides you a lot of out of the box improvements, as well as this other kind of tools in your tool belt to achieve your performance goals.
Definitely. Excellent. Thank you so much, Jason. I know we're past the hour, so I want to thank everyone for being here with us today. I hope you learned a little bit something. Always, please, as I mentioned, please go ahead and join us for the live weekly demo. And Jason, thank you so much. And I hope everyone have a wonderful week. Bye-bye.
Thanks, everybody. Thanks, Lucio.